Hello everyone. Hello everyone. Welcome to Pen and Paper. Hope you all are doing great. Today we've got this problem from definite integration and we are going to solve this problem using 5 different methods. So please make sure that you watch the video till the end. Here we proceed with the method 1. Here I need to evaluate this definite integral. So let me consider a function of type f of 2t plus 1 equals to 0 to 2 pi sine 2t plus 1 x divided by sine x dx. So basically over here all I need to get is f of 9. If I'm able to get f of 9, that would be my final answer, and f of 9, I'll get f of 9 at t equals to 4. Now if I consider f of 2t minus 1, the reason why I've considered this number as odd, f of 2t plus 1, because here I'm having sine 9x. 9 is odd, that's why I have considered over here an odd number 2t plus 1, and obviously t is an integer. So f of 2t minus 1 would be 0 to 2 pi sine 2t minus 1 x divided by sine x dx. Now if I do f of 2t plus 1 minus f of 2t minus 1, here I will get 0 to 2 pi. In denominator I will have sine x, and here I am going to get sine of 2t plus 1x minus sine of 2t minus 1x dx. Here what I'll do, I'll consider this thing, this 2t plus 1 as a and this 2t minus 1 as b. So if you look at this expression, this is in the form of sine of a minus b. So sine of a minus b, so this then gets evaluated to sine a minus b. I will use the formula of sine a minus b, that means 2 into 2 cos a plus b by 2, that will give me cos 2tx into sine a minus b by 2, which will give me sine x, and in denominator also I am having sine x. So these two will get cancelled. Here now I need to evaluate cos 2tx. So integration of cos 2tx is sine 2tx divided by 2t, and here I am having this 2. So 2 and this 2 will get cancelled. If I evaluate this from 0 to 2 pi, so this will finally going to become, because sine of 4t pi minus sine of 0, both are equal to 0. So from here what I concluded, that if this expression is finally becoming equal to 0, that means f of 2t plus 1 is equals to f of 2t minus 1. Now if I replace t with t minus 1, here if I replace t with t minus 1. So this expression would become f of 2t minus 1 is equals to f of 2t minus 3. Now similarly again I will go, if I go on replacing t with t minus 1, I will get this to be equal to f of 2t minus 5 and so on till f of 1. So to get f of 1 here, this was my function. To get f of 1, I need to put t equals to 0. So if I put t equals to 0, my this integration then becomes 0 to 2 pi sine x by sine x dx. So this will get cancelled. So finally I am getting 0 to 2 pi dx. So this would finally become, because here it is 1, integration of 1 is x, so x from 0 to 2 pi, this will give me finally, this will give me equal to 2 pi. So my answer is 2 pi. This was my method 1. Now let's look at method 2. So here, this is our method. This is our method 2. Here also, we are going to consider the same function, but we are going to do some different operation on it. 0 to 2 pi sine 2t plus 1 x divided by sine x dx. Here what I will do, this 2t plus 1, here I am only evaluating this term inside the integral. Here I will only evaluate this term inside the integral, and then I will integrate it from 0 to 2 pi. So this 2t plus 1 can be written as sine 2t minus 1 2t minus 1 x plus 2x dx. So I'm not writing dx actually, because I will integrate it later, and by sine x. If you look at this expression, this is in the form of sine of a plus b. So this will then become sine 2t minus 1 x into cos 2x sine a cos b cos 2x. So instead of cos 2x, I will write 1 minus 2 sine square x plus, because this is I am using over here, let me elaborate it further. Let me consider this as a and this as b. So this is in the form of sine of a plus b. So sine a into cos b. So cos 2x, which I have written as 1 minus 2 sine square x, and here it would be cos a, that means cos of 2t minus 1 x into sine 2x. So instead of sine 2x, I will write 2 sine x cos x. So 2 I am writing over here, and sine x into cos x. And here I am having sine x in the denominator. So this whole expression divided by sine x. And here sine x is there in the denominator. So this will cancel this sine x with this sine x. Now, if I multiply this with this, I will get sine 2t minus 1 x into this 1 divided by sin x minus this sin x will cancel this sin square x one time. So 2 due to this 2 into sine of this 2t minus 1 x into sin x, because this sin square x has been cancelled by sin x once. Fine. And here we have 2 cos 2t minus 1 x into cos x. So what we are going to do over here is, if we look at this expression, this is in the form of this whole expression is in the form of 2 sin A sin B, and this is in the form of 2 cos A cos B. So this 2 sin A into sin B can be written as cos, obviously a minus sign will be there due to this minus, cos A minus B. So if I'll do A minus B, I will get cos A minus B. So 2t minus 2 x minus cos A plus B. That means cos 2t x, and here this 2 cos A cos B, that means this is cos A plus B, that means cos of 2t cos of 2t x, cos of 2t x, this is cos of 2t x plus cos of A minus B. So cos of 2t minus 2x. Now I need to integrate this expression as well as this expression from 0 to 2 pi. But remember, this expression, integration of this from 0 to 2 pi, this and all of this would become 0. Let me explain why. If you look at this problem carefully, this term inside the cos is even, cos of 2t minus 2, this is even, cos 2t, this is also even, here cos 2t, this is also even, and cos of 2t minus 2, this is also even. So what will happen, let me consider if I have cos 2mx, where m is integer, from 0 to 2 pi. I am stating that this would be 0 whenever this term inside this cos is even. So this integration would be sine of 2mx by 2m and from 0 to 2 pi. So sine of 4 pi m minus sine of 0. So this whole expression, this whole integral then becomes 0. Similarly, if I integrate each of this from 0 to 2 pi, so each would turn out to be 0. So I would be left with only this one. Fine. If you look at this expression, this is nothing but f of 2t minus 1. So, and here this f of 2t plus 1 became equal to f of 2t minus 1. So if f of 2t plus 1 is equals to f of 2t minus 1, so similar to previous method, here I will replace t with t minus 1. So this will become f of 2t minus 1 equals to f of 2t minus 3. And if I again go on replacing t with t with t minus 1, so this would become f of 2t minus 5 and so on till f of 1. And to get f of 1, I need to put t equals to 0. So this integration would then become 0 to 2 pi sine x. If I put t equals to 0, it would become sine x, and here also it would become sine x. So finally its integration from 0 to 2 pi of 1 would be equal to 2 pi. Now let's look at method 3. Here we have method 3. Here what I'll do over here is, let me say this is sine 9x, right? So what I'll do here, I will use the formula of sine of 3a is equals to 3 sine a minus 4 sine cube a. So sine 9x can be written as 3 sine 3x minus 4 sine cube 3x. I can write sine 9x this way. So what I'll do over here, I will take sine 3x common. So this can be written as sine 3x into 1 minus 4 sine square 3x. Now this sine 3x, this is sine 3x. So this sine 3x can be written as 3 sine x minus 4 sine cube x. So if I am taking sine x common, this is becoming 3 minus 4 sine square x. Here I have written sine 3x. This is sine 3x. 3 sine x minus 4 sine cube x. So I have taken sine x common. So here I am getting 3 minus 4 sine square x. Now here I have 1 minus 4. Here it was sine 3x. Here we are having square of sine 3x. That means square of this whole expression. Square of this whole expression, that is sine square x into 3 minus 4 sine square x whole square. Fine. Now what I'll do, this integration then becomes 3 minus 4, actually square is inside over here, not whole square but this expression square. So if I square this term, this would then become, this expression would become 9 plus 16 sine to the power 4x minus 12 sine square x minus 12 sine square x, and here we are having outside minus 4 sine square x, and here 1, and here we are having sin x. So sin x into 3 minus 4 sin square x, and here also I'm having in the denominator sin x. So if I'm having sin x in the denominator, so this sin x and this sin x will get cancelled. So finally I will get 3 minus 4 sin square x, 3 minus 4 sin square x. Now remember, here I will use a trick. What I will do, I will not waste my time in multiplying each of this. What I will do, here I will look at the power of sign. The power of sign, the constant means it has 0 power of sign. Sin square x, sin square x, that means power of sign is 2 and the coefficient is minus 36. Here this sine to the power 6, this 2 and this 2 will make sine to the power 4, so I'm writing 4, and the coefficient of sine to the power 4 is minus 12 into minus 4, that is 48. Now sine to the power 6, that means this 16 into minus 4, this will give me minus 64, and here I am having, and obviously I need to multiply this with this term. Here I am having sine, this constant, that means sine to the power 0, and here sine to the power 2, and the coefficient is minus 4. So I will get this 6 will get multiplied with this 2 and I will get sine to the power 8x, and the coefficient would be minus 64 into 4, that means 256. Now to get sine to the power 6x, to get sine to the power 6x, this 6 will get multiplied with this constant and this power 4 will get multiplied with this square term to get sine to the power 6x. That means 48 into 4 minus 192, and this minus 64, this minus 64, and this constant term is over here, it is 3, and here the constant term is, obviously the constant term over here is 1. Fine. So to get sine to the power 6x, this 4 sine to the power 4 and sine to the power 2, the coefficient is 48 into minus 4, that means minus 192, and this minus 64 into 3, again minus 192, that means minus 384 sine to the power 6x. I mean, it is very important to use this kind of trick, otherwise we will waste a lot of time in multiplying each of these expressions. Now I will get sine to the power 4x. So I will erase this one, or let me use a different color to get sine to the power 4x. Here I will use, let me use white color. Now to get sine to the power 4x, this 4 will get multiplied with this 0, and this 2 will get multiplied with this 2. So 48 into 3, this 48 into 3, this would be 144, and this minus 4 into minus 36, this would again be 144, that means 2 here 288, let me write this with blue color, so 288 288 sine to the power 4x. Now I need to get sine square x. To get sine square x, what I will do, obviously this 2 will get multiplied with this 0 and this 2 will get multiplied with this 0. So minus 4 into 1, minus 4 into 1, minus 4, and this minus 36 into 3, minus 108 into minus 4, minus 100, minus 112 sine square x. And now I will get a constant, that means this 0 and this 0. This will give me, this is going to give me 3. This is going to give me 3. Fine. Now here actually 3 sine it was sine 3x minus 4 sine cube x. So if we took sine 3x outside, so here it should have been 3 actually. Here it should have been, this should have been 3. This expression, this one should have been 3. So here also it would be 3 and here also it would be 3. This should be 3 because 3 sine a minus 4 sine cube a. So over here to get constant, this would be 3 into 3. This expression would become 9. This is 9. Now I got sine to the power 8x. The power is even. Here also power 6x, sine to the power 6x, sine to the power 4x, sine square x. All the powers are even. So what we are going to do is, here we are going to use Wally's formula. That means if 8, here what we are going to write is 8 minus 1, 7, minus 2, 5, minus 2, 3 into 1 into pi by 2, and in denominator here it is 8, so we will write 8 as it is, 8, 6, 4, 2, and here it is 256. Similarly here it is minus 384 sine to the power 6x. So 6 minus 1 would be 5, then 3, then 1, and then again pi by 2, and here we will write 6 as it is. Now 6 into 4 into 2 and so on, and we have to integrate. Why I'm writing this? Because I'm integrating each of this expression from 0 to 2 pi. So I'm integrating each of these expressions from 0 to 2 pi, 0, 2 pi, 0, 2 pi. Here I am integrating 0 to 2 pi. So this will give me 0 to 2 pi, and obviously a dx will be there. So I am integrating each of them piecewise. So this is what I will get for each expression. Similarly, I will get some expression for this one also. But for this last term, I am going, if I integrate this 9 from 0 to 2 pi, I will get 18 pi. And on calculation, we can find that, we can easily, will come up that this whole expression from here till here, if I go on integrating this way using Wally's formula, I will get in the end minus 16 pi. And here we are going to get 18 pi. So 18 pi minus 16 pi would ultimately turn out to be 2 pi. So this was our method 3. Now I am going to use method 4. Method 4. This is my method 4. What I will do over here, let me consider I as integration from 0 to 2 pi sine 9x by sine x dx. So I know that integration 0 to 2a f of x is equals to 2 0 to a f of x dx, provided f of 2a minus x is equals to f of x. We have this property in definite integral. So this integral using this property, because if I put instead of x, if I put 2 pi minus x, this will remain same. So this I would then become 2 0 to pi sine 9x by sine x dx. Now again in this expression, if I put instead of x here, if I put pi minus x using this property, this will again remain unchanged. So again I will take 2 outside into 2 and this would become pi by 2. So this 2 into 2 is ultimately becoming 4. So let me rub this and let me write over here 4. Now let me consider only this quantity as I1. This is my I1. So this was my I1. So what I will do in I1, I will use, we know that integration 0 to a f of x is equals to 0 to a f of a minus x dx. Obviously a dx will be there. So using this property, this expression, if I replace x with pi by 2 minus x as mentioned over here, this expression inside this white boundary, which I have referred as, which I have termed as I1, this would then become cos of 9x, because sine of 9 pi by 2 minus sine of 9x is cos of 9x, and sine of pi by 2 minus x is again cos x, from 0 to pi by 2. Now if I add this I1 and this I1, I will get 2 into I1, 0 to pi by 2. In denominator, the LCM of cos x and sin x, it would be cos x into sin x. And here on cross multiplication, this would be cos of 9x into this sin x plus this sine of 9x into cos of x due to cross multiplication after taking LCM. So this is in the form of cos A sin B sin A cos B. That means this whole expression can be written as sine 10x, and if I multiply 2 over here and 2 over here, this expression would become sine of 2x. So this expression then becomes, this I am writing 2i1 again, 2i1 then becomes equals to 2, due to this 2, 0 to pi by 2, this becomes sine of 10x by sine 2x dx. Now the most important thing, what is our takeaway from this deduction? Here it was here it was sine of 9x by sine x. This 9x plus x became 10x, and this x, it was x, so it got doubled, so it became sine 2x. Now similarly, if I add this to I1 here, this was 2, fine, sine, okay, this is sine 10x, fine. Now what I'll do, so fine. Now what I will get, if I add this again, what I will get is I1 and 2I1. If I over here, it is very important to note that if I again apply this concept, this property, if I again apply this property, so we will see that f of 2a minus x is equals to f of x. That means if I replace x with pi by 2 minus x, so this will be followed. So what I will do here, like we took 2 outside and divided this by half, so this expression would then become I1 equals to 2, 0 to pi by 4, and here we are having sine of 10x by sine of 2x dx. So I will take this to this side and I will cancel this 2. So here, like we added I1 plus I1, I got 2I1, so I will add this 2 times, so 2 into I1 by 2 would be equal to, here I got 2 times, so 2 times, here 0 to pi by 4. And now if I do this expression once more, if I do this process once more, this 10x plus 2x will make it sine of 12x, and this 2x will get doubled, so it would become sine of 4x. So this 2 and this 2 is getting cancelled. So finally I am getting, this is I1, so finally I am getting I1 as 0 to pi by 4 sine 12x by sine 4x. So what I will do, I will replace 4x with equal to p. That means dx would be equal to dp by 4. So this integration would then become I1, this is I1 equal to 0 to this pi by 4 would become pi, as we have taken p is equals to 4x. Here I will get sine 3p by sine p, sine 3p by sine p, sine 3p by sine p, and here we are going to get dp, dx was dp by 4, and here we had this 2 was there, so this 2 will cancel this. So I am going to take half outside, I1 is equals to half this sine 3p by sine p. So sine 3p can be written as 3 sine p minus 4 sine cube p, 4 sine cube p. Let me write it over here. Let me erase this expression because We don't need this expression anymore. If you want to go through it once again, you can go back and you can pause and look at this expression again. But right now I am going to erase this part. And I'm going to write this part over here. And here in denominator I have sine of p. Fine. And I need to integrate this from 0 to pi. So this integration I1 would become equals to half 0 to pi. So this sine p will cancel sine from each of them. So here I would be left with 3 minus 4 sine square p, which I am writing as 1 minus cos 2p by 2. So this 2 will cancel this 2. So here I will get 3 minus 2, 1. 3 minus 2, 1. And here plus 2 cos 2p. And I need to integrate this expression from 0 to pi. So integration of 1 is x, integration of cos 2p, and here this 2 is there, so it would become sine 2p by 2, and here we are having this 2 and this 2 will get cancelled from 0 to pi, and obviously this half is also there. So integration of x from pi to 0, so this would become pi, and this sine 2p from pi to 0, so sine of 2 pi minus sine of 0, this would be 0. So here we are only going to get pi, and we are having this 2 outside, so this is ultimately turning out to be pi by 2. Remember, this is the value of I1, and our I is equals to 4 into I1. So our I turns out to be 4 into this I1. Our I1 is pi by 2. So finally we got 2 pi. Now let's look at method 5. This is method 5. Here this sine of 9x, using complex number, the sine of 9x can be written as e to the power I 9x minus e to the power minus I 9x. This whole expression can then be written as e to the power ix, and obviously here we are going to get this by 2. Here also e to the power minus ix by 2, so 2 and this 2 will get cancelled. Here I will get e to the power ix, and here this is e to the power I 9x. So this expression is then becoming e to the power I 18x minus 1 divided by e to the power I 2x minus 1 into this expression is e to the power minus I 8x. Now let me consider this e to the power ix as equals to a. So this expression then becomes a square to the power 9, because it is a to the power 18 minus 1 divided by a square minus 1, and here we are having a to the power minus 8. So this expression, this is a summation of GP, which is this. I am taking a to the power minus 8 outside. This is the summation of GP, which is 1 plus a square plus a square square and so on till a square to the power 8. This can then be written as summation a to the power a square to the power k. K varies, where k varies from 0 to 8, and here we are having minus 8 also, a to the power minus 8 also. Now let me replace back a as e to the power ix. So this summation would then become, now let me write this with blue, this summation would then become summation k equals to 0 to 8, and here a square, so e to the power 2ix into k, so e to the power I 2kx, and here we are having 8, so minus 8ix. So this is then becoming from k equals to 0 to 8, e to the power ix 2k minus 8, and we need to integrate this from 0 to 2 pi. Now using Cauchy's integral, along a closed curve, this I know the value of this expression 0 to 2 pi, because z equals to, this would be a unit circle with center at origin. So 0 to 2 pi e to the power I n x dx in general is equals to 0 for n not equals to 0 using Cauchy's integral, and is equals to 2 pi for n equals to 0. So this would be 0 when 2k would be equal to 8. That means when k would be equal to 4, then it would be equal to 2 pi, and for all other values of k, this would be 0. So using Cauchy's integral, this directly became equal to 2 pi, which is our final answer. Thanks for watching. Please make sure that you like, comment and subscribe to my channel. Thank you.